हेलो ग्रीटिंग्स फ्रॉम डॉक्टर सादिक अली। आज हम देखेंगे एक स्पेशल टाइप ऑफ द सीक्वेंस कॉल्ड एज अ बाउंडेड सीक्वेंस। क्या होते हैं बाउंडेड सीक्वेंस, कैसे कंसेप्ट होता है इसका? बेसिकली बाउंडेड सीक्वेंस इज अ सीक्वेंस सच दैट देयर ऑल टर्म्स आर ranging in between two real numbers is called as a bounded sequence. तो बाउंडेड सीक्वेंस को एक्चुअल में हम कैसे डिफाइन कर सकते हैं? तो डेफिनेशन रहेगी a sequence Sn is said to be bounded sequence if there exist two real numbers m and capital M such that m less than or equal to Sn less than or equal to m for all n. So it means that all the terms of the sequence are ranging in between two real numbers m and m. यहाँ जो स्मॉल m है और कैपिटल M है, ये दो रियल नंबर होते हैं। ये मे बी पॉजिटिव मे बी निगेटिव, इसलिए हम क्या करेंगे, स्मॉल m का एब्सोल्यूट वैल्यू लेंगे, कैपिटल M का एब्सोल्यूट वैल्यू लेंगे, उसका मैक्सिमम जो भी रहेगा उसको डिनोट करेंगे k से। तो ऊपर की डेफिनेशन कुछ ऐसे डिफाइन हो जाएगी कि देयर एग्जिस्ट अ रियल नंबर k such that the absolute values of all the term means mod Sn less than or equal to k for all n. Now we will see a sequence Sn is monotonically increasing sequence if Sn less than or equal to Sn plus 1 for all n, and this implies that Sn plus 1 upon Sn greater than or equal to 1. A sequence Sn is said to be monotonically decreasing sequence if Sn plus 1 less than or equal to Sn, that is Sn plus 1 upon Sn less than or equal to 1. And it is true for all n. Now, if the sequence Sn is monotonically increasing sequence and it is bounded above, then that sequence is always bounded. Bounded above का मतलब होता है कि सीक्वेंस इंक्रीज हो रही है, बढ़ते बढ़ते जा रही है और किसी पॉइंट पे आके रुक रही है. If the sequence Sn is monotonically decreasing sequence and it is bounded below, then also that sequence is bounded sequence. यहाँ पर भी वो डिक्रीज होते जाएगी और किसी नंबर पे आके रुक जाएगी, उससे ज्यादा कम नहीं होगी. Now we will see the theorem. Every convergent sequence is bounded sequence. For example, Sn is equal to 1 by n. This is the nth term. Take its limit as n tending to infinity, and its limiting value is 0. That means the sequence converges to 0, and therefore it is convergent sequence. And according to theorem, every convergent sequence is bounded. Therefore, this sequence, since it is convergent, it is bounded. Is every bounded sequence is convergent? That means, is it converse true? And the answer is no. Now consider one example. Consider a sequence Sn whose nth term is minus 1 raised to n, means minus 1, 1, minus 1, 1, and so on. So the range set of this sequence is minus 1 and 1. And this range set is a bounded subset of set of real numbers. Hence, the sequence is bounded. That means the sequence is bounded. But limit of Sn are minus 1 as well as 1. Hence, the sequence Sn is not convergent. It is oscillatory sequence. और जो oscillatory होता है वो convergent नहीं होता है. Therefore, every bounded sequence did not be convergent sequence. तो यहाँ हमने इस एग्जाम्पल के जरिए प्रूव कर दिया कि बाउंडेड सीक्वेंस कन्वर्जन नहीं होता है. Okay. Can we impose some conditions on the boundedness of the sequence so that the sequence will become convergent? Number one, if the sequence is bounded and if we impose the condition it is increasing and with LUB, that means least upper bound capital M, then we can say that the sequence is convergent and it is converges to M. Number two, if the sequence is bounded sequence and it is decreasing sequence with GLB, means greatest lower bound small m, then that sequence is also converges to that small m. तो ये इम्पोज करने के बाद आपको बाउंडेड सीक्वेंस कन्वर्जेंट मिल जाएगी. Now let us see one example, that is x1 is equal to root 2 and xn plus 1 is equal to under root 2 plus xn for all n greater than 1. Now we have to solve whether we will check whether this sequence is bounded or not. So first of all, this sequence is bounded and all the terms are in between 0 to 2 and hence sequence is bounded. Now this sequence Sn is increasing sequence. You can check easily. And suppose it's lambda be the LUB, that means it is a bounded as well as its LUB is lambda, therefore its limit is lambda. And when you take the limit on both sides, then you will get lambda is equal to under root 2 plus lambda. After simplifying, you will get lambda equal to 2. And therefore, this sequence converges to 2. Similarly, we can solve another example in which the first term of the sequence is 8 and xn plus 1 is equal to 1 by 2 xn plus 2. And this is true for all n. We can solve easily. We can show that it is a bounded sequence. It is a decreasing. It is decreases to its GLB lambda. You take the limit in terms of lambda, solve the equation, and you will get the value of lambda. Okay. Now one more theorem. If limit Sn upon n is equal to non-zero number, then that sequence is not bounded. यहाँ पर nth टर्म को n से डिवाइड करना है, लिमिट लेना है, लिमिट का आंसर 0 नहीं आना चाहिए, 0 के अलावा कुछ भी आएगा तो बाउंडेड रहेगी. Now see one more theorem, that is if Sn is bounded, then limit Sn upon n is equal to 0. That is the contrapositive of above theorem. But if Sn is equal to log n, that means nth term is log n, then as n tending to infinity, Sn tending to infinity. Therefore, Sn is not bounded. But limit of Sn upon n, using L'Hopital rule, it will become 0. That means this is the counter example in which we can say that since the sequence is not bounded, still its limit Sn upon n is equal to 0. Now see one more theorem. If Tn is bounded and Sn is converges to 0, then new sequence Tn-Sn is also converges to 0. Now I hope that you understood all the things. I am signing out. Stay blessed. Bye bye.